The best answer seems to be probably not. But there may have been life in the past, and future exploration of Mars might turn up fossils preserved in the rock layers.
Mars is in an ice age now, but at several times in the past it's been much warmer because enormous quantities of water flowed on the surface. The question is exactly when did that happen and why? And is it connected to similar changes that have taken place on the Earth? If we can find out when and why this took place, we may be able to anticipate future changes like this on the Earth.
Once we get beyond the orbit of Mars, the distances between planets become enormous. Jupiter, the next planet out, is over 800 million kilometers from the Sun. That's about 5 times further away than the Earth. The 5 outer planets, Jupiter, Saturn, Uranus, Neptune, and Pluto, are far different than anything we find in the inner solar system. Except for Pluto, which is an oddball, these planets are larger and far less dense than the rocky planets of the inner solar system. Basically, they're huge volumes of gases and liquids. Jupiter is practically the same composition as the Sun, about 90% hydrogen and 10% helium. Jupiter is a giant of the planets. With more than double the mass of all the other planets put together, it exerts so powerful a gravitational pull that it can hold on to the hydrogen and other gases. In fact, when we look at Jupiter, what we're really seeing is the top layer of clouds in an enormously deep atmosphere. One of the most fascinating features is the Great Red Spot, which was first observed over 300 years ago. This cloud feature turns out to be a huge storm, big enough to swallow 3 Earths. One of the most surprising discoveries we made at Jupiter was that there was a faint ring surrounding it. Jupiter has at least 15 satellites, which form a miniature solar system as they orbit Jupiter. The 4 largest satellites of Jupiter form a particularly fascinating story. We think they're composed mainly of ice and some rock. And you would think in the extreme cold so far away from the Sun, where ice freezes to a solid as hard as rock, that these objects would be geologically dead. And that does seem true for Callisto, the outermost of Jupiter's large satellites. This is an icy world almost totally covered by impact craters, an extremely ancient surface. But as we get closer to Jupiter, the satellites become more and more dynamic. Here's Ganymede. Lots of impact craters in some areas, but we also see features that show that parts of the surface are relatively young. Europa has hardly any impact craters at all. And this is the satellite Io. Not a single impact crater to be found anywhere. Far from being a geologically dead world, it is one of the most active bodies in the solar system. So far we've discovered at least 9 active volcanoes on Io, the only place other than Earth that we've ever seen volcanic activity. It came as a total surprise to everyone that these satellites should be so different from one another, and they should show evidence of continuing internal activity. And the surprises continued at Saturn. Saturn is almost a twin of Jupiter in size and composition. Saturn too is kind of a mini solar system with its 23 or more satellites. Saturn is about 1.5 billion kilometers from the Sun, and therefore extremely cold. But even out here, we see signs of internal activity on some of the satellites. There are, of course, the usual impact craters, but in addition to these ancient surfaces, we also see some very, very young ones. Evidently, some internal processes are still going on here today. But you mention Saturn to people, and right away they think of rings. They're made mostly of small ice particles that have been pulled by Saturn's gravity into a thin layer less than 1 kilometer thick, but over 250,000 kilometers wide. The rings may have formed when a satellite broke up into pieces, or they may be chunks of ice that were never able to come together to form a larger body. we see a lot of activity in the rings. In fact, we can see the patterns in them change almost from minute to minute. Once we leave Saturn behind, we know less and less about what's beyond. Distances are so vast that we have trouble getting any good information. These photographs are about the best views we can get of Uranus and Neptune, although we've used other sophisticated techniques to get a pretty good idea of what they must be like. If all goes well, in a few years, a spacecraft will be flying past these planets and sending back even more detailed information. Uranus is tipped almost 90 degrees toward the Sun. It has 5 known satellites, and in 1977, a system of 9 rings was discovered. Neptune has at least 2 satellites, but no rings that we know of. When we finally get data from our spacecraft, we'll probably find that Neptune and Uranus also turn out to be active, dynamic systems like Jupiter and Saturn. And this is Pluto, right now just a point of light in our largest telescopes. In fact, the only reason we can tell it's a planet is because from night to night it moves against the fixed background of the stars. Pluto has a satellite, which we can see as a small blob on an enlarged image of Pluto. It's thought that Pluto and its satellite are made of frozen gases. Some scientists don't even think Pluto is a true planet, but merely an escaped satellite of Neptune. And are there any other planets beyond Pluto? Well, right now we don't really think so. But like so many other questions in planetary science, it's one we can't answer for sure just yet.
Many of the details are still unknown, but the outline of how the Sun and the planets came into being is clear. Before there was a solar system, there was a solar nebula, a vast cloud composed mainly of hydrogen and helium. Slowly the nebula condensed and separated into distinct bodies. The largest of these became the Sun. Several planets, each made up of a slightly different mix of materials from the solar nebula, took shape at various distances from the Sun. Early in its history, a strong wind of particles from the Sun blew most of the lighter elements far into space. The heavier elements left behind formed the rocky inner planets. These are relatively small because the solar nebula contained little of the material that rocks are made of. The gaseous giants formed in the deep cold far from the Sun. These planets are huge because hydrogen and helium were plentiful to begin with. A few large bodies in the solar system are nearly dead worlds today, but they are the exception. Almost everywhere we have looked so far, the planets and their satellites have proved to be surprisingly active. Conditions on some planets have changed dramatically and relatively quickly, not just once, but several times. This includes Earth. At present, conditions here are very favorable for life. But this may change, either through natural processes or through our own doing. If we learn in time why conditions changed on other planets, it may teach us how not to cause unintended and possibly harmful changes on our own planet.